Good afternoon, everyone. It is my pleasure to welcome you to be part of Bridge to India's webinar today. I am Sangeeta Suresh, and the topic of today's discussion is digitalization for renewable assets. I am delighted to introduce our panelist for today with you. We have with us Mr. Julien Deckx, Product Manager, Digital Solutions 3E, Mr. Amit Kumar Mittal, Executive Director and Head of Operations, Radiance Renewables, Mr. Saurabh Mehta, Head of BD and Regulatory Affairs, Mahindra Susten, and Mr. Rajesh Thakur, Head of Performance Monitoring and Analysis. Mr. Aarti, if you can move to the next slide, please. If you can move to the next slide, please. Mr. Rajesh Thakur from Tata Power, and Mr. NOBRE, VP Asset Management and Performance from Cleantech Solar. Welcome, panelists, to this discussion. Thank you for being taking time out, and a special word of thanks to 3E for sponsoring this event and enabling us to bring great content to our audience. So a little bit about today's event and the flow of discussion. Our webinar will be an hour and a half long, and it will be moderated by Mr. Vinay Rustagi, Managing Director, Bridge to India. He will make a brief introduction, followed by a presentation by Julien from 3E. This will be followed by a panel discussion, and as always, we will take questions at the end from the audience. So that is all from me. Over to you, Vinay.
Thank you, Sangeeta, and I hope everybody can hear me. So thank you and welcome to all the panelists again for joining us. It should be hopefully a very insightful session for all the listeners. You know, the renewable sector has become a game, if I can say so, of very fine margins. There is a huge pricing and cost pressure, obviously, and then that means immediately that the costs need to be optimized, the product design needs to be optimized, and then of course all the other parameters in terms of maintenance, cleaning, etc., need to be fine-tuned too. And that is where digitalization is coming and playing a bigger and bigger role. We do hear lots of fancy words and jargon, things like IoT, AI, ML, predictive analytics, etc. We hope that we can uncover and unravel some of the mystery behind some of this jargon. We also hope that through our panelists, we can kind of really discuss some concrete examples in terms of what is actually happening in the industry today and what are the kinds of savings and gains which are possible as a result of various digitalization initiatives. So without further ado, and before we go on to the discussion, let me pass over to Julien, who will kick things off with a presentation on the topic. Julien, over to you.
Thanks a lot, Vinay. I think Sangeeta will share the slides. There you go. Okay, well, also from my side, thank you so much for everybody who's joining in. Indeed, a small presentation from me and from 3E before we kick off the panel. So if you can go to the next slide, I'll start by briefly introducing 3E. So we are a Belgian-based company of about 120 experts worldwide, but concentrated on Europe, South Africa, and India. So quite a big presence in India. If you go to the next slide, so then our mission and vision. Our vision is that we believe in a world where renewable energy will be affordable and available for all. And our mission, very relevant, of course, to this panel, is maximizing the value of your renewable energy assets through data intelligence, digital innovation, and expert services. On the next slide, we can see a bit an overview of the Synaptic clients that we have all over the world. You can see there the presence in India. It's quite concentrated there on that part of the map. So we have 4 gigawatt peak connected in India, about 8 gigawatts of signed contracts, big customers like Renew Power and others. We have local support in India, dedicated servers. India is really our second home, I would say. A little bit about myself. So I'm the product manager of this beautiful digital solution on our Synaptic platform. By the way, the previous slide was about plants connected to our Synaptic platform. We also have a big consultancy business next to that. And solar analytics is one of the applications there for advanced analytics. I'm a product manager for this solution. I've been in the renewable industry for only 2 years, so I'm very humbled by all of the years of experience that the other panelists have. I do bring 12 years of experience to the table in project and product management around big data, analytics, AI, etc. So I'm very well versed in the digital technology, and I can of course channel the 22 years of experience of 3E in this domain. So in the next slide, I'd like to just briefly talk about something that is probably well known to everybody, but just to set the stage here, this is a session about digitalization. So just to remind you that digitalization is not the same as digitization. Digitization is just a conversion from an analog to a digital format. Digitalization goes much beyond that. It's really a transformation of a business through digital technology. And a little bit of history of that. If you may or may not know that a computer, that word used to mean something very different. It used to be a job. A computer was someone who would compute, and large groups of people would each compute a subset of, for instance, weather forecasts. Now, the problem with that was that a weather forecast for 6 hours ahead would take 6 weeks to compute in that manner. So you can imagine that wasn't a very viable model. And the very first proper computer, the ENIAC, was actually used to do weather forecasts now in a viable time frame. So that's that's one of the first examples of digitalization, where something that wasn't possible before was made possible thanks to digital technology. And the reason I'm using this example is, of course, not only because it fascinates me that weather forecast is one of the first digital applications, but of course because weather is very relevant to the world of renewables. If you go to the next slide, so weather plays a key role and is of course one of the core competences of 3E as well. So we are very good at interpreting satellite data, turning that into irradiation data and other meteorological variables, and also to, based on historical data, to make long-term yield assessments through a model of the plant where we predict the energy output. So that's another very good example of digital technology creating value, and in this case, it's optimizing a project, and it's obtaining financing by having very good forecasts, long-term forecasts of what the yield is going to be. But we didn't stop at that at 3E. So 12 years ago, we thought, okay, let's implement this energy yield model in an operational phase. And if you can go to the next slide, the reason why we did that is because a traditional way to measure performance is PR. Now, PR is a very simple formula, doesn't require much digitalization, but it can fluctuate a lot. For example, if you have an over-dimensioned plant, if you have a very high irradiation, and definitely in combination with low temperature, you're going to have more inverter clipping, and your PR is going to go down, even if your performance is perfectly fine. So there is noise on the signal. If the PR is going down, you don't know if it's performance going down or some other artifacts. And that's what you can sort of filter out if you have a digital twin of the plant, and you calculate the expected output, and you measure you divide the measured energy by the expected energy. That gives you the energy performance index, and that's a much more stable signal, if you will, than the PR. It will vary much less. There's less noise, and you can much earlier detect the real underperformance of the plant, because you can separate it from the noise in that signal. So that's another value created through that digitalization, which is increasing the yield in the end through early detection. But still, we're not stopping at that. And that's the next slide, where digitalization is an ongoing process. You can implement more and more complex algorithms that will create more and more value, going from hindsight through insight and then to foresight. And in terms of insight and foresight, we took a giant leap end of last year, where we launched our solar analytics, which, as shown on the next slide, will break down the gap between that expected energy and the measured energy into all these loss categories, of which quite a few of them are recoverable losses, so you can do something about it. So in other words, we identify the root cause of losses fully automatically, and it's not early detection, it's instant detection. If there is a fault, the system will detect it instantly and allow you to fix it very early and not lose energy while you're unaware of some performance issues that don't show up in your overall KPIs. And I have a short example on the next slide of a plant of one of our customers, where we did a retrospective analysis. So they didn't have our advanced analytics at the time. But in the green bars, you're seeing the energy performance index, which typically fluctuates between 90 and 95% for that plant. Goes down a bit in winter because of shading and snow. But then suddenly in April and May of 2020, it went below 85%. And at the time, again, they didn't have this technology, and it took them many hours of manual analysis to figure out that they had an issue of inverter temperature derating. So inverters were basically overheating. So what this shows us, in this graph, we can see the automatically calculated loss from that inverter derating. So it shows us that with our system, they would have known right away what the issue was. But even more interestingly, as you see the circle on the left side there, you can barely see it, but you have little red lines where we already were able to detect this inverter temperature derating 1 year earlier, before there was ever a drop in EPI or PR or any of these KPIs. So what this shows you is that they could have had that foresight. They could have noticed that there's a potential overheating problem with that plant, and they could have fixed that in advance, thanks to this technology. Just one more example of foresight on the next slide, just very briefly, and to sort of close the loop with the weather forecasts. So we also have yield forecasts, which can, for instance, be combined with the loss analysis to forecast future losses, and then to calculate a return on investment on an intervention, for instance. So that's another example of foresight. And then just my very last slide, just to leave you with one thought. What I see as the final frontier is then to work not only on a plant per plant basis, but if you look at our database, which is growing tremendously, of plants, we have all of these plants in our database in different climates, different configurations. We have these digital twins of each of those plants. We have operational data. This is a wealth of data that we can leverage to improve recommendations, not only operationally, but also to have some kind of predictive design, if you will. So a design based on known information of which devices will perform well in which conditions and which configuration. And that will, of course, have tremendous value to minimize risk, further strengthen financing, maximize profit, etc. So just a little thought that I want to launch, maybe to discuss on this panel, or maybe to discuss next week, when we'll be at the Renewable Energy India Expo in Greater Noida. I'd be happy to discuss this with anyone and all the other topics that we'll cover today. So looking forward to that, and I'll leave it at that for my presentation. And yeah, looking forward to the panel discussion. Thanks.
Thank you, Julien. I'm happy to say that I think I understood most of it. So that's good. I just wanted to ask you a quick follow-on question. I mean, you mentioned, I think you mentioned digital twin. What does that exactly mean? Can you please, explain that to us?
I'll be happy to. We love to talk about our digital twin. So as such, the digital twin is a model of a digital model of the plant, of all the devices, how they are connected, etc. And that allows us to model for a given set of weather conditions, model the energy output of the plant. And you can have different ways of doing that. A lot of products will have a self-learning digital twin that will learn from historical data of the plant, learn how to replicate how it will behave in certain conditions. What we have that, but we also have a physics-based digital twin, which, independent of historical data, will predict the outputs. And the advantage, of course, is if you have a self-learning digital twin and you have underperformance in the plant, this digital twin will consider that underperformance, quote unquote, normal. It will not be able to identify this underperformance. And with the physics-based digital twin, you have sort of a objective baseline for what the performance should be, and it allows you to identify underperformance in a more detailed way. But both have their pros and cons and can be used for different applications.
Thanks, Julien. Let me come to Rajesh. Rajesh, it will be very helpful for all of us if you can really kind of explain to us some of the technical language, particularly terms like IoT, AI, and ML, and how do they translate into real opportunities and benefits for the renewable projects, and then go on to also explain what you as a company are doing in this space.
Yeah. Thanks, Vinay. So, Vinay, I will start first with why today everybody is small background, as I understand it, talking about digitalization, AI, ML, deep learning, etc. So today, with the extensive use of your computers and software-based technologies, each business as such has and generates lots of digital information. The renewable assets with thousands of solar modules, hundreds of inverters, multiple wind turbines in a single wind farm, and then there is a weather-related data. It generates a huge amount of data, huge amount of information. This information is as such is already digitalized by means of Scada. So Julien has rightly explained there is a difference between digitization and digitalization. So the information is already digitized for the renewable assets. But now this information is still still a siloed information, right? It's available at plant level. If my site person has to take some decisions, he still needs to process that information or interpret that information before it takes some decisions on it. So to get the ready-to-use analysis, right, which is useful for taking the decisions on the performance insights, this information further needs to be integrated, processed, correlated, and analyzed for insights in terms of their impact on each other, because all these parameters, right, at plant level and weather parameters, they are interdependent on each other, right? And then collectively they impact my overall performance of the plant. So the digitalization is not just a single technology. Okay? It's integration of all these technologies, systems, your processes, your manual processes, and I will say it should be throughout the entire value chain of your renewable ecosystem. So now we are all aware that unlike conventional energy forms of energy, where the resources, right, the availability of these resources is known, and to great extent these are predictable. The renewable energy, on the other hand, is dependent on the resources which are highly unpredictable. So it is all the more and very important to ensure that my assets uptime is maintained at maximum. My assets are operating at highly efficient level, so that for any given level of resource, my assets are able to maximize the output and there is no opportunity loss. Now to do this, to achieve this, I need to have those insights into my asset performance, and for which I need to integrate all this humongous amount of data at one place, so that I can derive those insights from this data. Having said that, there are well-known advantages of digitalization. The transformation, that is the digital transformation from classical way of working to a data-driven way of working, is not always easy. Classically, most of us are tuned to take decisions based on our knowledge based on our past experience. And this usually happens when further information insights are not readily available or need some efforts to derive those insights. Another challenge, I will say, in the digitalization is the way the organizations are cultured. In almost all organizations today, if we see the data is, a lot of data is generated among the functions, departments, but very little is shared other than the end use of data with the other departments. So as organizations, I'm not taking the advantage of this siloed business intelligence, right? So through digitalization, what is required is to integrate all this information at one place. So that so the management or the organization can take those informed decisions, data-driven decisions. So with the information in the entire value chain is digitized and digitalized with the manual processes integrated with them, the entire value chain of say a renewable cluster gets benefited, right from planning, engineering, procurement, quality, O&M, vendor performance management, inventory management, and so on. So now I will come to your question of some technical jargon of digitalization. So frankly, I'm not a IT expert. So Julien, you can pitch in if I'm going wrong somewhere. So I will try to explain this in a simplest manner the way I understood it. First come to the Internet of Things. So this is basically a system, a network, which is connected system wherein per se site level equipments, sensors, softwares, applications are connected over the internet. Okay, and then this information is available to me at a digital platform or any digital platform for further analysis of that. So the IoT is also called as IIoT for industrial. So IIoT is basically industrial Internet of Things, where it is useful for industry. So this typical IoT device in day-to-day use are your smart cars, smart lights, smart refrigerators. We can call them as the IoTs, which can be connected on your Wi-Fi, which can be connected on your internet, and then you can operate them from remotely. You can monitor them from remotely. The well-known applications of AI in day-to-day usage are your smartphones, smartwatches, connected cars. By being IoT, they can transfer the data to the OEM manufacturers. We can further diagnose your cars and all that. When it comes to renewables, it is individual assets through various sensors and systems like Scada. When connected over the internet, we will refer to as IoT. This information, when available through IoT, can then be used for various analysis by using AI, artificial intelligence, and ML tools to derive useful and data-driven actions, including various predictive analytics. So that is, as per me, the IoT. Julien, you can add to it. Now comes the artificial intelligence. So artificial intelligence is the main branch of prediction-based technologies, which churns out a lot of data and come out with the insights from that data based on the pattern and behavior of that data. It includes domains like your machine language, machine learning, neural networks. In the simplest forms, the AI, the artificial intelligence, refers to the systems or machines which can mimic the human intelligence to perform the task and can improve themselves. Like machines can always, or most of the times, do it better than the human beings and repeatedly at the same level of performance. So when it comes to intelligence, so how do the human beings become intelligent, right? So from our childhood, we learn things by observation, by our experience of good and bad results of our actions, and also from our educational learnings. This process of gaining the intelligence to carry out certain tasks by taking decisions is artificially developed into the machines and systems to either take decisions themselves or help us to take those decisions based on the analysis of huge amount of data based on their intelligence, which is gained over a period of time by mapping the historical data, by mapping the patterns from those historical data. So these machines get that intelligence, and then they either take some decisions themselves, actions themselves, or they can support our decisions. So in short, AI system processes a large amount of data much faster and obviously make predictions more accurately than humanly possible. Not impractical, but humanly possible. So examples of AI/ML maybe in day-to-day life is your speech recognition. The good examples are Alexa and Google Home. Image recognition, which is your face unlocking on mobile, Facebook photo tagging, traffic alert, chatbots, and so on. So at Tata Power, we are making use of all these technologies. So we have integrated all our sites through IoT at our digital platform in Mumbai, which we call it as a CCRA, Common Control Room for Renewable Assets. And then we are utilizing this data other than a basic usage of real-time monitoring and descriptive analytics for more advanced analytics in terms of intraday, day-ahead generation forecasting, predictive and prescriptive analytics for inverters, for our SCBs, for our wind turbines, as well as maintenance planning of our RE assets. So yeah, Vinay, that's my understanding, basic understanding of these jargons.
No, thanks, Rajesh. That's very, very useful. Before we go into more detail of the various applications, I do want to delve into a little bit on the operational aspects. And I remember, when I was doing my own MBA and we were doing some data courses, there used to be a saying called garbage in and garbage out. In the Indian renewable context, I've heard a lot of problems in the way the sensors are set, the data is collected, etc. So, I know from previous discussions with Andre that, it is one of a topic that's close to his heart. So maybe Andre, we can bring you in here and you can really just tell us what are the various problems that you face in collecting the right kind of data? What kind of data do you collect? I ask you particularly because you are an operator of a distributed portfolio with a large number of assets in multiple countries. And how do you really kind of minimize the errors? What have been the learnings along the way?
Thanks, Vinay. Well, first of all, thanks for inviting me to participate in this event. And well, before I answer your question, let me just briefly talk about Cleantech Solar. At the moment, we have about 600 megawatts running. India is also our home turf. As Julien was saying, second home. Majority of our assets are in India, but we do have systems all the way from New Delhi to Jakarta. So 4,000 or 5,000 kilometers separating these two locations. We have about 550 sites. So our scatter systems is quite substantial. And just looking at the Julien map just now, I was impressed because I can tell that not a lot of players worldwide would have data from all the variety of these locations, especially in Asia and Southeast Asia. Well, a lot of people think we are a CNI player. We started as a CNI player, deploying PV systems at big MNC factories, Coca-Cola, Nestle, Kellogg's, and all these kind of players. But as time passed, we realized that some of our clients had smaller roofs, and developers were saying no to these systems. We install a lot of smaller systems ranging from, let's say, 100 to 500 kilowatt peak. And in fact, we took the ultimate challenge, which was to accept that one of our shareholders, Shell, asked us to solarize their petrol stations across many of the countries that we operate in. So as an example, Malaysia, we have 250 petrol stations in Malaysia, have solar systems on top, and we're monitoring all of these sites. So you can imagine we were dealing with hundreds of 50 or 70, 80 kilowatt peak systems. On top of that, now we have solar farms. So a lot of people know this, but Cleantech now has many solar farms in India, mostly in Maharashtra and Tamil Nadu. Later on, we can talk a bit about these sites. But the reality is a lot of people think that a solar farm would behave differently than a rooftop. But once you're talking about data, I don't see a solar farm or a rooftop or a floating PV system. We have a floating PV system or a petrol station. To us, it's all the zeros and ones, and I have to keep the asset running at full throttle. Of course, if the solar farm has issues, I lose a lot more money, but nonetheless, the data flow on these hundreds of sites is tremendous. And next week, I'll be in India as well for REI, and I'll chat with Julien more about database and volume of data. We're swimming on data. A lot of people say, how can you deal with that? And of course, the answer is computers. We have a team now of 35 full-time staff, and I can tell you now, out of 2 or 3 new hires, at least one is a programmer, or even half of the new staff are programmers or people from IT background. I'm sure the colleagues here at the panel will have similar experiences. Don't get me wrong, we still need engineers to take care of the assets, but we need a lot of the IT guys to help us. And to cover the Vinay question is, definitely the garbage in, garbage out is a big thing. We have a solar farm in India, and the performance ratio is showing at the moment 105%. So I keep scolding my team, keep telling them, guys, the Radiance reading is wrong, because the energy is fine. We're collecting our checks, we're making money, but I keep hammering to people like the logger is lousy. Either the provider, the data provider, to fix that, or we're deploying our own meteorological station, because this is clearly wrong. That's why we also we have a blend of readings from the ground and satellite data, because a lot of readings are questionable, especially in countries with a lot of soiling, and the sensors get dusty. And I actually wrote a paper a few years ago about this challenge, and whoever writes me, I can share a copy. But this is then the garbage in, garbage out. You have to do a lot of checks and balances before you can tell with certainty about the performance of a solar system. And this requires years of experience before you can tell an investor or a client that the performance of the system is all right. And looking forward to talking more about the topic of data quality and system performance for the rest of the event.
Andre, just very, very quickly, in a minute or two, if you can, what are the key lessons you've learned in trying to improve data quality?
Well, first and foremost, we operate a few key sites with research grade instruments, and in those sites we get 99.7 or 99.8 data availability. So and sometimes we have to deploy monitoring systems that are not as good as those because of cost pressure, and then right away we feel the pressure. We get only 99% of data or 98.5% of data. So right from the get-go, you already have less data, depending on the quality of the hardware and even of the software. And then once the data is flowing, you have this secondary, let's call it secondary issue, where the performance ratio is 110% or 100%, and then the data is rubbish, right? And then even if you have 99.7% of data, but if the irradiance bad, you're not going to make any good use of it. So it's really a fight. My team is constantly struggling with the engineering division of Cleantech, saying you cannot cut corners with hardware and software in these systems sometimes. And the colleagues here can comment. The hardware and the software monitoring system is only a few. This is not even a full percentage point of the cost of a solar system. It's like 0.3, 0.2%, depending on the size of the system. So you cannot deploy multi-million dollars of assets and then fail at the final stage by deploying a lower cost solution. So yeah, so Vinay, we need to boost this kind of data quality, data availability for the data acquisition side of things.
Sure. No, thanks, Andre. I think that's very, very insightful. By the way, just wanted to welcome. Sorry, Julien.
No, go ahead. Sorry.
Okay, I just wanted to welcome Amit. Amit could not join earlier, but good to see Amit. Welcome to the webinar.
Thank you.
Thank you. So, let me come to you, Saurabh. So we talked about data. I know that the Mahindra Susten team has been one of the early movers into this digitalization space, particularly with their experience in in-house project development, EPC and O&M. So just tell us a little bit about how you have basically embarked on this journey. What have been the kind of, in terms of implementation, what's been the actual implementation journey has been? What have been the key challenges that you've faced? And then maybe you can just talk about a little bit about some key applications that you're kind of focused on.
Sure, Vinay. Thanks a lot for giving me this opportunity to speak on this particular topic. So, for us, of course, the other panelists has so far, discussed a lot about, digitalization in the operating assets. We believe, the digitalization should start from the conceptualization of the asset itself. So that means in renewable energy context, from the day the bid is there, from the RFA stage itself, we try to synergize the digital applications and create a kind of synergized system which will cater to all the aspects of that particular asset, starting from the tender requirements, the site selection, power evacuation selection, then project development, procurement, construction, everything, including after commissioning, the operation and maintenance part of the asset. So in Mahindra Susten, as we are having experience of developing more than 4,000 megawatt of projects. So we have kind of ample data pool that in any particular asset, what may go wrong. So that using that pool, we have created a kind of a system wherein suppose I just would like to give you an example that suppose we are developing an asset in Rajasthan. So in Rajasthan, what all kind of challenges will be there with respect to land, with respect to power evacuation, with respect to any regulatory compliances. All those things will be already built in that system. So whenever I'll be bidding for new project or whenever I'll be constructing a new project in that particular region, I can straight away pull the past learnings from that digitalized pool of the previous learnings and start creating our system from there onwards. Second thing is, as and when we keep on getting new challenges, new learnings, new insights, all those things will also be fed on continuous basis, on real-time basis on the system that we have created in-house. So using that kind of digitalization experience that we have, we are creating kind of a system. We call it as GIST. The full form is generalized intelligent system, generalized intelligent synergy tool. In short form, it is GIST. So this GIST will cater to all my future projects, whether I'm bidding for new projects, whether I'm constructing new projects, whether ongoing projects are being kind of repowering is happening on the existing projects or not. And second, because as we are aware, in this renewable energy business, it is basically now it is a kind of there are a lot of divestment activities will keep on going on. There will be a lot of M&A activities will also be going on. So if we have this kind of repository where all project related documents, project related information, everything is at one place, it is easier not only for us but also for the upcoming investors and upcoming the players to consider those projects in their investment decision. So that is from with respect to
that is with respect to creation of assets, and of course while managing the assets, what Julien has suggested, what Rajesh has also suggested, the data part is right now is of much more value. And specifically now, because of this forecasting and scheduling regulations are being stringent from various regulatory commissions, we have to be very sure what are we going to predict, and we have to be very sure that not only weather but also my plant performance should also be accurately predicted, and then only we will be able to manage our assets properly going forward.
And Saurabh, are you able to talk about any one or two key applications that you have that have played a major role in your portfolio, optimizing your portfolio?
Yeah, so that's also that is the system that I was talking about, the gist that we have created in-house in Mahindra Susten. So that basically covers all the aspects of the synergy that I was talking about. So it has been created in-house. So you are also talking about the challenges or the issues that we have faced during this journey of digitalization. So there also I would like to share one interesting point that Mahindra Susten has a kind of very good domain experience in developing any solar assets and managing the solar assets, but we are not having any in-house expertise in developing software applications or the digital applications. So during those days when we are trying to create this particular application, we are facing some challenge because the guys who are creating this application, the software team, they are not having any domain experience, and the domain guys were not having any experience of software. So creating the synergy between these two teams were a little bit difficult, but somehow then we tried having a kind of different training sessions from domain team to software team as well as from software team to the domain team, and tried to bridge that gap. So now I think we are kind of very very good development that we have made for this particular development of GIST tool that I was talking about.
Thanks, Saurabh. Let me move on to Amit now. Amit, Radiance is one of the, relatively speaking, one of the newer kids on the block in terms of a project, being in the project development business. But you did acquire a very large portfolio of assets, rooftop assets. So just wanted to understand how have you gone about implementing digital solutions, particularly on legacy assets, and any key application or business case that you can point to, which has been kind of played a very fundamental role in your business.
Thank you, Vinay. Just a very short, in case some of you may not be knowing about Radiance. So Radiance is a green growth equity fund company, and we are the developer for the cost-effective renewable solutions, and we cater only for the C&I market. So yes, Vinay, we acquired a portfolio which is around 150 megawatt in capacity, but the challenge lies that we have got more than 1100 project sites. So it's quite a big challenge to manage such a vast portfolio, especially in terms of the diversity. The size of the projects could be as small as, say, 20 kilowatt to the as large as few megawatts. One of the most important thing what we find is that that there was no communication between the plants. So the one of the key what we realized is that we have to establish a very effective and efficient central monitoring platform, because unless we know that what exactly is happening on the plant, we are blindfolded and it's not possible to effectively manage the plants. So we had our central monitoring platform. The one what we have selected at that point of time was keeping in view that yes, we are going to acquire this platform, so that is capable of handling both the ground mount projects as well as the rooftop portfolio. So some of the key initiatives what we did was that first is immediately to set up the communication network across all the sites, installing the data logger and the communication networks, and then making sure that those particular sites communicate to our central platform. Because the number of sites were so big, it's not possible everything to do it manually. So we also have to do a lot of innovative things. One of the way was that we have to deploy the bots to quickly integrate the data, so that if if we arrange the data in a particular format, then automatically those boards will read that particular information, and it will do the automation in terms of the integration of the sites to the central monitoring platform. Although it will require some supervision to make sure that yes, everything is flowing in a correct way, but it helped us a lot. Otherwise 1100 sites manually configuring was going to be a very, very difficult task. Then what we did is that it's not only the performance monitoring, we took it even to the next 2 more levels. So we use that particular platform as an asset management, so that along with the performance, we also use for the effective ticket monitoring of the assets. If there is any preventive maintenance, or if there is any breakdown maintenance, or any of the activities, the ticket will be raised, the SMS will go to the relevant operator. He will know precisely what exactly is the problem in which particular site, which inverter number or what component, and then he can go and fix that particular thing. We also added some more innovative things into that. Even the safety compliance also we integrated into our this asset management tools. So like if a person visits the sites, we are sitting remotely at Mumbai or Delhi, how do we make sure that the safety compliances are being taken care of? So we also built some intel around that we make sure that before the person goes there, he takes the selfie with the geotag and loads into the system, and then he gets the permit to work on that particular site. So these are some of the innovative things we did. And then the last piece what we did is that we integrated this particular system to our ERP system, so that the generation data is automatically fetched into my ERP system. I can do my invoicing, and rest of the accounting system also can be done using the same system. So with this integration, now I have got a end-to-end control, starting from the check on my performance to the managing the assets to the my billing, and everything can be done in one single platform. And yes, we could see a considerable improvement in the overall performance once we have implemented. I would say it's work in progress, but yes, it is showing very positive results. But it was a very tough task to integrate such a large portfolio into the central monitoring platform.
No, absolutely, Amit. Thanks very much for that. I can imagine, particularly with such small sites, and that was spread over a very vast geography, how that could have been so difficult. I wanted to ask you, Julien, you obviously operate in multiple geographies around the world. Have you noticed any perceptible difference between India and other markets, either in terms of how digitalization is being adopted, what are the various applications, etc., or even in as a result of that, in observing differences in project quality and performance? Anything you can share about comparison of Indian market with others would be interesting.
Sure. If I may, I would love to first react on a couple of things that I heard in what the other panelists said.
Sure.
So first of all, Andre, thanks for noticing our nice geographical spread. And if I may add, it's also a nice mixture of CNI and utility scale plants, which also makes it very interesting. So Andre mentioned the garbage in, garbage out thing, and I want to connect that a little bit with what Rajesh was saying about AI and machine learning. I think we're getting to a bit of we're a bit beyond the hype on AI ML, and we see that some things don't work out as we thought they would, like self-driving cars. It's taking a bit longer, etc. And I think it's very important to understand that AI ML, we talk a lot about deep learning, which is sort of a black box method. You don't really know. You pour a bunch of data in and something comes out, and that's of course very sensitive to the garbage in, garbage out reality. And so that's why it's important to not only use these AI ML methods, but also physics-based methods that will actually include domain knowledge into the algorithms to recognize when it is garbage and when it is not, and filter through it. And you know, because deep learning, there's some very fun tools nowadays where you can generate images with deep learning. You can generate anything, things that don't make sense at all. So the domain knowledge is needed, and that I want to connect with what Saurabh was saying about that struggle of, you know, the domain knowledge on the one hand and software knowledge on the other hand. Beware of flashy AI companies that can do deep learning, but they don't know what they're talking about, and you'll get some results. You'll always get results, but they may not always make sense. And yeah, at RE, of course, we have domain experts and we have software experts, so we combine both. So that's just a little bit the thread I saw throughout the conversations here. To get to your questions, Vinay, your question. So the first thing that comes to mind when thinking about India is, of course, the scale of the plants. I was looking this morning when preparing to our system, and our top largest 5 plants in our system are in India. So that's a whole different scale. I think someone, I forget who said something about, in the end, whether it's, you know, whether all of these inverters are in one plant or split across several plants. In the end, it's all ones and zeros. So that's also true. I mean, it's not a whole different ball game, I would say. But it's really interesting to have those plants as well. The other thing I think about when comparing Europe to India is, of course, the cost of labor, which is very high in Europe, and combined actually with that smaller scale of plants, you get fewer people who are on site, usually no people at all on site. So you would think that's pushes for digitalization, but on the other hand, we heard all of the challenges that were mentioned by everyone in getting that data, cleaning that data, etc. It's not scalable to continue doing that just through manpower, as you know, companies are growing really fast, and you can't have people manually record every downtime of every inverter in all of these portfolios, and so that's why in terms of digitalization, I think the nature of the challenges is maybe a bit different between Europe and India, for instance, but the need for it is just as big. Yeah. I think you're muted, Vinay.
Sorry, Julien. Any quick comment on what you see on the project performance, build quality, uptime, etc.?
Yeah, I think maybe the low with the more on-site presence, the low-hanging fruit, things that are easy to detect on-site, are maybe less prominent in the typical plants that we would have in India, whereas in Europe, maybe there are some very obvious things that are missed, just because in Europe, yeah, there's less on-site presence. But other than that, yeah, the very special losses, like, you know, temperature derating and some types of degradation and MPP deviations and things like that, that's something that, yeah, it's humans cannot really detect. And there's some monitoring softwares more and more in India as well that will do these PR calculations, and that will have some relatively simple analysis, but they will still miss the more complex losses that will still are able to increase the performance in a portfolio by just that percentage point or a few percentage points more.
Sure, Julien. Thanks. Now, you know, some of the applications or the use cases that we've heard, I mean, to some extent, this sounds very obvious. Whether, for example, what Saurabh mentioned was in terms of using digitalization for designing a project, or reducing the, you know, something like predictive maintenance, etc. Why has it not been done already? Is it? Would you say, Rajesh, that we are still in kind of early phases and still discovering the true potential of digitalization? What is the pace of progress on this front?
Yeah. So Vinay, I will agree. Particularly in the renewable front, we are in the early stages of digitalization. Because as Amit has also said, for any results to be seen, you need some years of data, right? Your algorithm has to learn from that to become more accurate. So yes, we are in the early stages. We have those systems in place. We are progressing on that. But as the time will go by, these algorithms, this AI ML models, they will learn from the data they capture over the period, and then their effectiveness and their benefits will be more and more visible going forward.
Understood. Thanks, Rajesh. So I wanted to understand, we obviously there are lots of opportunities to optimize performance, increase the project output, reduce downtime, etc. What are the biggest, are there any kind of low-hanging fruits, Saurabh? Where have you seen the biggest opportunity, in terms of just quantifying that in terms of the bottom line or the, let's say, performance ratio or something like that? And if you can give some numbers, for example, over the period by way of some of the lessons you've learned, applications you've developed, what kind of improvements that you've seen in the business portfolio?
So this portion also I'll ask, I'll give the answer in two parts. One is before asset gets created, and one is after asset gets created. So of course prior to coming to that point, you were saying this particular tool, while it is not being used extensively in renewable energy field. So I'll give you one answer from my side in addition to what Rajesh has just mentioned. So one of the key reason is every company will have their own processes, their own set of doing the work. So there is a need of a customized tool according to the requirement of a particular company or a particular business. In renewable energy, there are so many business models are there, and every business model will have a different set of requirements. So we have to create a customized tool which will cater to the requirement of a particular company or a particular business model. So that is the reason it is not a very standardized approach that can be used by anybody. So for example, that I was talking about in Mahindra Susten, because we have the experience of more than 10 years of developing and running the project through and through, starting from RFS and then land selection and everything. So using that insights, using that the know-how, we have customized a process first, and that process was digitalized using various tools available into the market. So that's how there should be the approach if you would like these tools to be used by all the renewable energy players. Now coming to your point of the creation of value using the digitalization. So in my view, this of course has two kind of value addition. One of course is a qualitative, another is a quantitative. Qualitative one would be I will be able to work on several projects, several bids together, because all the inputs and all the data and everything is there in my tool. So I just have to select a particular site, select a particular region, and the tool will give me all the major inputs required for participating in the tender. So one of course would be ease of participation, ease of development of the project. This will lead to faster execution of the project. So the moment the project will be executed faster, it will have its own cost advantages like reduced IDC, reduced capex and all those things, and ultimately it will add to my IRR. So digitalization will of course have a value addition, provided the tool that is being used, it should be properly configured. Now after the project is commissioned, the asset is created, then comes so during operation and maintenance phase, of course the performance management is one part on which all the panelists has already spoken a lot. Other part that I was talking about is the forecasting and scheduling regulations that India has. Now right now the norms are being stringent. So every so earlier it was plus or minus 30%, plus or minus 35% accuracy level was required by the regulatory commissions. Now it has been reduced to 20%, then some cases 15%. and every breach of that particular every percentage breach in that accuracy will have a huge you can say kind of impact on your overall revenue, and which will impact your bottom line. With this digitalization of the assets during operation and maintenance, we can substantially reduce that particular revenue loss, and that itself can increase my IRR by at least 50 to 100 bips, depending upon the regulatory regime that I am in, depending upon the state or depending upon the central regulation. So I see the digitalization will have a tremendous value, not only during operation and maintenance, but of course prior to during the project development stage itself.
Thanks, Saurabh. So I just noticed that we don't have any questions from the attendees yet. So a request to everybody on the webinar, there is a questions box on your screen. If you have any questions for any of the panelists, please do enter these, and we will have time at the end to take some questions. Let me come to you, Amit. I don't know if you want to react to anything that Rajesh or Saurabh said, but I did want to pick up one of the implementation themes with you. We're all talking about digitalizing all the data, developing multiple applications, using, like you said, using it not just for enhancing performance, etc., but also running your day-to-day operations. Now, is it all one integrated setup being done by one vendor, or do you have multiple technologies, multiple systems speaking to each other, and how you are kind of coping with that? How are you kind of dealing with that?
Yeah. Okay, so just a couple of points from the previous discussion. So I think there is no doubt about this, that digitalization is helping everyone, and I would say that it also has to do something with the overall improvement in the country infrastructure. Today, if you see, the connectivity is available even in the remotest area, because previously we used to have one biggest constraint, that wherever the projects are there, you don't have the data connectivity, you have to take a special lease line. Now most of the places we find that like 4G, 3G is easily available. So the availability of the infrastructure also have supported the more and more moving that everyone to move to the digitalization. Now coming to the number of platform, yes, actually there is no one answer to that. It all depends that what is my business need, what type of information I require, what type of dashboard I require. I would like to say one more thing. Today, sometimes we are in a different situation. We have so much of data and we don't know what to do with that particular data. So I would say that first very important thing is that yes, we may collect 100 data points, 1000 data points. It's very, very essential that we set our goal very clearly, that out of that, what is important to us, how we process the data so that we make meaningful information out of the data. Otherwise, sometimes the mere too much of data confuses more than the solving the problem. So that's very, very important. And while we selected our platforms and customized that, we kept that as one of the focus area, that what is my business need, what information is crucial to my business requirement, and how do I get an information on that. To give an example on that, we track typically on a renewable plant that what is the lost energy, because fuel is free for me, so every lost energy is a loss to me. So if I focus on that, then how do I bucket that? Once I bucket that lost energy, it can be the grid failure, it can be the soiling losses, it can be the weather, or it can be so many other things. Once I bucket that I can focus more clearly that yes, where I'm losing my revenue, where I'm losing my energy, and then how do I concentrate, how do I improve my overall performance. Another point is that now coming, do we have one single platform or multiple platform? Yes, what we try to do is that we don't keep too many platforms, because then the one of the issue also becomes that how the one platform communicates to the other. So we use the capacity of a particular platform to its maximum extent, and yes, beyond that, if there is a limitation, then obviously we go for a second platform. If I give an example, in our case, we broadly divided into 3 platforms. One is my platform which I do for the performance monitoring and the asset management. Then on top of it, I have put a BI platform, because being a C&I customer, even if my plant could be one, I may have even the 5 customer, 10 customers connected to that. So I need something much more than that, which even the system can capture, because for the system it is only one plant, but while I have got a 5 different customers. So I have put a BI intel over that, where I can do the some more. I get the data from the same my monitoring platform, but then I can do the different dashboards, the different analysis using the BI platform. And then the thirdly, I use my ERP system, where I can do my financial accounting and everything using that particular thing, so that my generation data is already picked into that particular thing. So the short answer is that yes, we can use the multiple platforms, but then the key is that we should make the effective communication between these platforms, so that like it's not creating trouble, it's solving for my problems rather than creating an interface issue. That is what we take.
Thanks, Amit. So I don't know if Andrew is still with us or not. I can't see him on the screen. But I guess this is a question for all the panelists. It seems like we are well on the path to digitalization. There is lots and lots of data. The plants are aging as well. So I'm sure there are more issues coming out. Performance is becoming more crucial to manage. What next? What are the kind of, starting with you, Julien, what are the next priorities for you in terms of developing new products or finding new applications over the next few years?
Yeah, so that's a little bit, my last slide that I showed, I guess it's really leveraging the database of all the data that we have. Since we have it in a well-formatted way, we have that physics-based digital twin for every single one of these plants, so we can compare them apples to apples. By the way, we also have, to get back to the garbage in, garbage out thing, we also have a automated sensor check that will compare irradiation sensor data to satellite data to identify things like soiling or shading of the sensor. So we have a very high quality data in our database, and of course we continue developing our algorithms that operate on a plant-to-plant basis. But for the mid to long term, I think we're going to be focusing on mining that data as a whole and to apply that to different stages of the product development. Another thing I want to mention is about, someone mentioned the sort of funnels in which different parts of the organization operate. For instance, the yield assessment is often made in another software than the monitoring. We have the advantage that we have that physics-based digital twin that allows you to do the long-term yield assessment, and you can do that in one and the same platform. So that's also part of our long-term vision for our Synaptic digital platform, is that it's a platform that will integrate data in every step of the life cycle of a plant, and hence break the walls between all of these different silos.
Okay. Rajesh, Saurabh, do you want to take that in turn? Rajesh, starting with you.
Yes, Vinay. So, Vinay, the next steps for us, we already have our in-house platform. We call it the CCR. It's a common control room for renewable assets. It already has around 70 sites, solar sites, and 22 wind sites connected. Now, it's as Julien said, it's a huge data, right? It's already there. We are already into the real-time monitoring, the descriptive analytics. The next stage would be in terms of analytics, would be to go for the predictive analytics. So we are into inverter anomaly prediction, working on that, wherein my system or my platform will tell my O&M teams when it is likely to fail, right? So that they can take those corrective actions proactively and save that much of downtime. Similarly, on the module cleaning, which is again a critical part of any solar plant, right? So it can recommend the site teams based on the AI, ML, and the historical data, and as well as the weather prediction which is the intraday or the short-term prediction. It can tell my O&M team when to take your module cleaning next. For example, suppose tomorrow there is a prediction of very good sun out there, so I will tell the system will tell my team, go and clean more modules, incur more cost in cleaning, but it will benefit you tomorrow because it's going to be a sunny day tomorrow. So such types of insights we are planning to give it to our site teams. On the design front, on the front end front, see, earlier we had a CCRA version, that the platform, the user interface was such that the user has to go to the multiple pages, right, to get those insights. So today we are developing, and in fact we have developed a user-specific dashboard. So when he logs in into the system, he gets all the information required for him to take those decisions, what he is going to do today, which inverters he is going to look into because of their lower performance. What is my generation now and what it is going to be in next remaining period of the day. All this information would be available to in one place. He did not go anywhere else other than to do a further deep dive into it. Then the systems also has the basic functionalities like real-time monitoring, then the inverter analytics of start and stop. So the next step for us would be to go for predictive analytics, making this platform as a common platform, as Amit was also saying and you were asking. So everything is available at one place. So earlier, for example, the reviews were used to happen outside, right? And during the review, there used to be some requirement of how this particular inverter is doing, why this inverter, how many times this inverter has tripped, whether this inverter is repeatedly tripping. Now to do this, I have to go again to my digital platform and see those trend analysis. We're trying to combine this now. So bring in that review management platform also on CCRA. So wherein my business heads can review the performance of the plants from there and there itself. And at the click of button, they can go into the further analytics of it. The other advantage of bringing everything on the same platform is the data quality. The moment you have different platforms and different data entered in the different systems, there is a challenge in having the same data at everywhere. So that is another advantage if we bring everything at one place.
Thanks, Rajesh. Saurabh, anything to add to that?
I wanted to add something, Vinay.
Yes, Andre, please.
Yeah, so guys, I have been working with PV for 17 years and in Cleantech 7 years. And first time I went to India was 7 years ago when I joined Cleantech. I was a bit shocked because it was November and I couldn't see the sky in New Delhi, right? The sky was gone. And that is why I had written a paper back when I was with Ceres about air pollution in Singapore, which is of course a lot less, but it causes losses on PV systems from time to time. And then I wrote a version for New Delhi. And this is something that I started talking to colleagues in India. I said, guys, let us create a database of system performance for India, because people think they can get 1,400 kilowatt hour per kilowatt peak in New Delhi, and that is not true. I knew this was not possible, and once the data from our system started to roll in, it was obvious, right? We get 1,100, 1,200, 1,250 if we're lucky, right? If anyone has 1,400 in New Delhi, give me the data. I challenge you to give me 1,400 in New Delhi. You cannot, right? So I wanted to create a database, and this, of course, is challenging because people want to keep their data close to their chest, right? And then I was like, okay, I have an idea. With my scientific background, I said I will start writing papers, because in a paper I don't say Coca-Cola or Nestle or Kellogg's. I say PV system 1, 2, 3, PV system 77, PV system in Cambodia, PV system in Thailand. So I started writing these papers with the performance of the systems of Cleantech solar. If my boss finds out, I probably can get in trouble. But I said, I don't care. I'm going to write these papers anyways. And I've done this for the past years, and I can pass the publication to people if they want. But now I'm asking the colleagues here in the panel, and also I will be at REI saying the same thing over and over again. Let's create some sort of public database on system performance across entire India. And I know other people like Julien has data from other countries, but let's focus on India. And Bridge to India tried that. I think a few years ago, you guys asked us to submit some data. But my point, my gripe is that people may cherry pick. And when I wrote the papers, I put 100% of the data. So you see like, whoa, Cleantech has some lousy PV system in Cambodia or in Malaysia, because the goal is to have a trusted source of electricity, solar PV, because there are enough rooftops and there are enough land and solar farms and reservoirs for floating PV for everybody. You guys want to deploy, I don't know, what is the Modi's latest number, 100 gig, or has the number changed recently? 500 gig. Okay, so there are enough gigawatts for everyone. So let us start a database, and then people really know, like, okay, this part of India is really troublesome, right? Maybe for the next PV system someone does there is a database showing that soiling in months X, Y, and Z are really challenging, because if the performance of the systems of the other colleagues here go up, right, the whole industry will benefit, because solar will become even cheaper, right, across the board for everyone, and then we can all prosper together. I just wanted to share this message.
No, absolutely, Andre. I think the point is well made, and we've had various requests over the years of trying to assimilate and learn some lessons for project performance and try to break down even though we're not really a technical consulting company, but still just try to understand what are the key challenges in optimizing performance, what are the key issues faced by the sector. But I think for various reasons, sometimes there are genuine commercial reasons, but otherwise, I just see a lot of sensitivity at part of the developers in sharing any data, even anonymized data. I don't know if anybody wants to kind of comment on that, but I agree that exercise should be quite useful.
If I may react, indeed, I somehow see also a bit of a lost opportunity in the fact that we have here 4 companies that face the same challenges, that need the same type of system, and that have to some extent developed their own system, which undoubtedly works well. And of course, I'm not objective in saying that, but wouldn't it be a better world if they're all using one platform, and if all that data is being used together? I think that would be a solution, and then of course, if it would be Synaptic, that platform, by coincidence, that would be even better for us. But I'm joking a little bit, but I am serious about that fact that it's very fragmented, and I'm also curious about the motive of people to go for their own platform, as opposed to have using existing solutions, because detecting soiling is detecting soiling. You're maybe some of you do it better than others, but in the end, it's better if everybody pulls the resources into one company specialized in data, and that can give the optimal solution to everybody.
No, fair point, Julien. I think, unfortunately, we don't have the time to discuss that. But we do have some very interesting questions from the attendees. So let's take them as quickly as we possibly can. This is the question which we've already discussed to some extent, but I guess, Julien, you can take this very quickly. On a scale of 1 to 10, where do you see the maturity of Indian companies on the path to digitalization?
what is the maturity of digitalization in India?
On a scale of 1 to 10, 1 to 10. In the sense that it varies a lot. I mean, you have maybe, I would dare say, especially the large players are quite mature in that, and maybe there are, but we see here that there are players that are less large and still already heavily invested in digitalization. So there's, I think, because of what I mentioned about the manpower, I think some companies, I guess, can get away with less digitalization, but a lot of them have understood the importance of it, and there's probably a gap in between that's gonna close very soon.
So can we say roughly 6 or 7?
Yeah, is it a weighted average, or is it? I don't know how to calculate this number. So
right.
I think it's all over the map.
Okay, sure. So there is a question about Scada integration of string inverters for mega projects, say something like 500 megawatts or so. The question is that still seems to be very difficult. How is a seamless integration possible for such a big project with string inverters? Seems like a technical question, so maybe Rajesh and Saurabh, one of you can take it.
Yeah, I think better, Rajesh can take that query. But from my side, what I can say, it's of course difficult, but it can be doable. So in Mahindra Susten, we have done similar kind of string inverter configuration in Dubai for around 350 megawatt, I think 400 megawatt projects. So I think it is doable, but of course I am not that much technical. So better Rajesh can add into that.
Yeah. So Saurabh, you rightly said it's challenging. The volume is huge in terms of configuring it, but it's doable. It's only the volume, and there are techniques by which you can reduce this volume, right? Instead of taking string by string, you can pull it, cluster it, and then do the IoT part of it, connect it with your platform. So challenging but doable.
Okay.
So just to add to that, we also have got our 70 megawatt project under construction, and that is also on the string inverter, and we have just started the work of integrating everything to the central monitoring platform. So it's little tricky and difficult, but as such, not much challenges.
Okay. But it's a wealth of data that you get out of it for that plan, so it's worth it.
Yeah.
Only thing, system needs to be designed properly, including the communication system.
For sure.
Sure.
Yeah. Thanks, Amit. So this is a question specifically for Julien. You mentioned that you support developers by way of energy yield, i.e. optimizing or enhancing energy yield. What has been your experience of accuracy level, particularly in the recent past?
So this is about long-term yield assessments, long-term yield estimates.
I presume so. It's not very clear to me. Yes.
I'm going to have to let you down because that's the part of the business that I know a bit less. So I couldn't tell you. But if this person gets in contact with us, I'll be happy to connect them to. Oops, I'm losing the light here. Connect them to the right colleagues, which can answer that question better than I can.
Sure. Okay, and then there is a question for Andre. It is how to ascertain very early on what is the degradation of modules, and if that is within the guaranteed range, given the pyranometer measurement related issues, which are kind of tend to be in the same range.
Vinay, this topic is another 1 hour discussion at least. But let me explain something. And I wrote a paper 10 years ago about degradation in Singapore and of systems in Singapore. And it is way more than Europe, right? Or America. And that was a kind of like a first warning. And I put some theories back then that now are easier to prove. But what happens with a lot of our PV systems near here, Singapore, Malaysia, Thailand, is that the tilt angle of the systems are on rooftops, right? Because this is our bread and butter. the roof tilt angles are very shallow, like 3 degrees, 5, 7. So the PV panel ends up being installed at very shallow angle. No one cares about the tilt and orientation because you're able to get 1400 and 1350, 1450 of yield. Everyone is happy. The return on investment is there. But what happens is it rains, right? And the water ponds at the bottom of the panel, and then the dust starts to bake onto the glass, and then the glass starts to get stained forever. You cannot clean that. You can grab all chemicals of the world, it will the stain on the glass will not go away. So if you talk about ultimate degradation, you have to discuss module degradation or what I call system degradation, because the system degradation is way more than 1%. I can tell you that. Now, if you go challenge the module manufacturer on the warranty, you say, hey, the system is degraded 2%. The first thing they will say is, what is the tilt angle? Because we've tried this before. And then they say, okay, no, this is not in line with the recommended manufacturer's installation manual. So your claim is void, right? So, and even sometimes they might take the panel and they'll clean the hell out of the panel and put in the flash test, and then the panel will behave. Let's say, okay, the degradation is within the expectation. But then I tell people, are you going to clean every panel on that roof, 1,000 panels, as good as the lab people did? They will not. You can have all the cheap labor in the world, the quality of the cleaning in a 40°C roof, the guys are under the sun the whole day. Believe me, I've been on top of so many roofs in Asia, it is scorching, right? So the quality of the cleaning is not as good as when you're doing a lab test. And then you have this so-called system degradation, which is a big concern. And so when reporting degradation, you're going to have a lot of opinions. That's why I said this is a 1-hour topic, because a lot of people will say, no, it's within the limits. But within the limits, okay, the panel is at 15° tilt in a nice solar farm. That one, I guarantee that the warranty is fine. But once you start talking about shallow rooftops, that's a different ballgame.
Great use case for predictive design, by the way. It's something that you could get out of a big database and present to to engineering teams so that they avoid that.
Okay, so we do have quite a lot of more questions, but I think in the interest of time, we will finish here. So I want to thank Rajesh, Saurabh, Amit, Andre, and Julien again. That was a very, very insightful and useful session. I hope everybody attending the webinar also agrees with me. The key takeaways, I think there is no doubt that the commercial pressure of the sector is increasing. Project sizes are increasing, the sector size itself is increasing, and then the plants are aging as well. So the bottom line is that there is more and more data available, but subject to some data integrity and quality issues, there is a massive scope for better learning and better digitalization and more applications, etc. I think to me it seems like the question is not really how far we progress down, but it is about identifying the right application and the right avenues for exploiting that data, capturing the right data, and finding the right use for it. With that, we will end the session here. I will pass over to my colleague Sangeeta for some final closing related formalities. Sangeeta, over to you.
Thank you, Vinay. And thank you all for being a part of this really interesting session. And I'm sure there's a lot more to discuss. We would like to especially thank 3E for sponsoring this event. Thank you for being here with us today and enabling us to bring great content to our audience. The team from 3E will be present at the REI Expo in the coming week, and they will be showcasing their flagship product, Synaptic, in booth number 14155 for those you who are interested, so please join them. Bridge to India will also be present at the REI Expo. We will be hosting 2 sessions, one on the 28th, and the topic is very similar to today's discussion. It is the role of digitalization for renewables. Once again, a member from 3E will join us along with a few of the peers of the industry to sort of take this conversation we had forward a little bit more. The other session that we will be hosting is on the 29th, and this is on the topic of the need for technical standards for solar BOS components. Mr. Vinay Rustagi, our managing director, will be part of the CEO conclave, and he is also the jury member in the REI Awards. So we are very excited to be a part of this event, and we look forward to meeting you there. And for now, that's all from Bridge to India. Thank you.
Thank you.
Thank you.
Thank you.
Thank you.